For countless generations, humanity has gazed up at the moon, seeing it as a symbol of constancy, a silent companion in the night sky, always present, always watching over us. Its gentle glow has inspired wonder, curiosity, and a sense of connection to something greater than ourselves. We've written poetry about its beauty, painted its likeness, and imagined stories of its mythical inhabitants. The moon has been a muse for artists and dreamers, a canvas for our hopes and fears, and a source of endless fascination. When astronauts set foot on its surface for the first time, they described it as a place of magnificent desolation, a landscape both haunting and awe-inspiring, unlike anything seen on Earth. This image of a dead, static world is deeply ingrained in our minds, shaping how we think about the moon and its role in our universe. But this is a profound misunderstanding. The moon is far more dynamic and mysterious than we once believed. The moon is not just a passive observer, it's an active player in our past, present, and future. Its gravitational pull shapes our tides, stabilizes our planet's tilt, and has influenced the evolution of life itself. It's a cosmic archive, a strategic outpost, and a treasure chest of resources waiting to be explored. The moon holds clues to the early history of our solar system and may one day support new human settlements. Its secrets are hidden in its geology, encoded in its dust, and buried in shadowed craters that have never seen sunlight. Each rock and crater tells a story billions of years in the making. We are on the cusp of a new lunar era, one that will redefine our relationship with our celestial neighbor. New missions and technologies are opening doors to discoveries we once only dreamed of. The moon is a gateway, not an endpoint, a key to understanding our origins, and a springboard for our destiny among the stars. It offers a unique vantage point for science, exploration, and even the future of humanity beyond Earth. As we prepare to return, we're not just revisiting an old site, we're opening a new chapter in the human story. This time, we go with new eyes, new tools, and a renewed sense of purpose. The moon's true potential is only beginning to reveal itself, promising discoveries and opportunities that will shape the future of exploration for generations to come. To truly grasp the moon's significance, we must journey back in time to the chaotic dawn of our solar system, a period when the cosmos was a swirling sea of dust, gas, and newborn stars. Over 4.5 billion years ago, our solar system was a place of constant collisions and dramatic change, where planets were still forming and the future of Earth was far from certain. In this violent environment, Earth was a molten, seething ball of rock and metal when a Mars-sized protoplanet named Theia hurtled through space and collided with our young world in a cataclysmic impact. The force of the collision was unimaginable, vaporizing huge portions of both worlds and blasting a colossal cloud of molten rock and debris into orbit around the Earth. Over millions of years, this debris slowly gathered and coalesced, drawn together by gravity, until it formed what we now know as the moon, a companion born from the chaos. The moon is not an alien object in our sky. It's forged from the very same material as Earth, a true sibling, our planet's lost twin, forever linked by their shared origin. Unlike Earth, which has been reshaped by oceans, weather, and tectonic forces, the moon remained geologically quiet, preserving a pristine and untouched record of the early solar system. Every crater on its surface tells a story of ancient impacts and cosmic violence, a history that has long since been erased from Earth's ever-changing face. By studying the moon's geology, scientists can read the earliest chapters of Earth's autobiography, unlocking secrets about our planet's formation and the tumultuous events that shaped it. The moon serves as our portal to a time of cosmic bombardment and planetary chaos, offering a window into an era when the solar system was a far more dangerous place. By analyzing its ancient rocks and mapping its countless craters, we piece together the story of our world's violent beginnings, gaining insights that would otherwise be lost to time. The moon is a silent historian, holding the missing pages of our planet's baby book, a cosmic archive, waiting for us to unlock the mysteries of our own origins. The moon's influence goes far beyond its shared history with Earth. It became the architect of a stable environment where complex life could arise. The moon acts as a planetary stabilizer, anchoring Earth's axial tilt and ensuring predictable seasons. Without it, Earth's tilt could swing wildly, causing catastrophic climate shifts. The moon's gravity also drives our ocean tides, creating dynamic tidal zones. Billions of years ago, these tides may have been the laboratory where life first emerged. The moon stabilized our climate and stirred the chemical brew in our early oceans. Without the moon, complex life on Earth might never have evolved. Its presence is a key ingredient in the recipe that makes Earth a living world. The moon is not just a companion, it's a co-creator of life as we know it. Earth's surface is constantly recycled, but the moon has remained almost unchanged for billions of years. This makes it a cosmic time capsule, a library of the solar system's history. The countless craters on its surface are scars from the late heavy bombardment, a violent era erased from Earth. The lunar regolith is a complex archive, bombarded by the solar wind and preserving particles from the sun's ancient past. By analyzing lunar soil, we learn about the sun's evolution and the cosmic radiation Earth has faced. The moon has also collected fragments from asteroids and comets, offering samples from across the solar system. Studying this archive is a compelling reason to return. By drilling into the lunar crust, we can read the history of our solar system layer by layer. The moon holds answers to fundamental questions about our origins, answers lost on Earth. It is the solar system's attic, filled with priceless heirlooms. As we set our sights on Mars and beyond, escaping Earth's gravity remains a monumental challenge. Launching rockets from Earth is expensive and inefficient. The moon's gravity is only 1/6 of Earth's, with virtually no atmosphere. This makes it a strategic staging ground, a natural spaceport for the cosmos. We could assemble and launch missions from the moon with far less energy and fuel. The moon is close enough for quick travel, yet already outside Earth's deepest gravity well. It's the essential stepping stone for humanity's leap into the solar system. The moon was once thought to be bone dry, but we now know it holds water ice in permanently shadowed craters near its poles. This discovery is a game-changer for space exploration. Water is essential for life and can be split into hydrogen and oxygen, powerful rocket propellants. The moon could become a self-sustaining refueling depot, supporting human life and fueling spacecraft. The lunar regolith is rich in oxygen and metals like iron, aluminum, and titanium. Advanced techniques could turn lunar dust into building materials for habitats and infrastructure. Helium-3, rare on Earth but abundant in lunar soil, could one day power clean fusion reactors. The moon is a warehouse of resources, enabling a permanent human presence beyond Earth. In situ resource utilization will reduce our dependence on supplies from Earth. The moon is not a wasteland, it's a provider for our future in space. The moon's geology is stranger than fiction, with massive lava tubes beneath its surface. These hollow tunnels, formed by ancient lava flows, could be miles long and wide enough to house entire cities. Lava tubes offer natural protection from radiation, temperature extremes, and micrometeorites. They are prime real estate for future lunar habitats. The moon also experiences moonquakes, caused by Earth's gravity and temperature swings. These quakes can make the moon ring like a bell for over an hour. Understanding them is crucial for building safe structures. The moon's mascons, dense regions beneath impact basins, create gravitational anomalies that affect spacecraft. Exploring these features will reveal more about the moon's history and provide unique environments for survival. Returning to the moon is about more than science. It's about building a new branch of human civilization. For the first time, we're imagining what it means to truly live, work, and grow on another world, not just visit it. The moon will become a proving ground for our ingenuity, resilience, and adaptability as a species. Long-term habitation in low gravity will reshape our bodies, technology, and culture. Everyday life will demand new ways of moving, eating, and even thinking. We'll invent tools and routines to help us thrive in an environment where gravity is just a fraction of what we know on Earth. The psychological impact of living under a black sky, with Earth as a distant beacon, will inspire new art and philosophy. Our sense of home and identity will evolve as we gaze at our blue planet from afar, sparking creativity and reflection in ways we can only begin to imagine. A unique lunar culture will emerge, shaped by shared experience on a new world. Traditions, celebrations, and even language may shift as people bond over the challenges and wonders of lunar life, forging a community unlike any on Earth. The far side of the moon is perfect for radio telescopes, listening for signals from the dawn of the universe. Free from Earth's radio noise, we'll peer deeper into space and time, unlocking cosmic mysteries that have eluded us for generations. Underground labs could host experiments impossible on Earth. Shielded from radiation and temperature extremes, these facilities will allow us to study new materials, biology, and physics, pushing the boundaries of what's possible in science. As families and future generations join lunar settlers, education and creativity will flourish in unexpected ways. Children will grow up with a dual sense of belonging to both the moon and Earth, shaping a new perspective on humanity's place in the cosmos. We might even build a lunar space elevator, revolutionizing space transport. Such innovations could make the moon a gateway to the rest of the solar system, opening up possibilities for exploration and commerce beyond our wildest dreams. But this new frontier brings legal and ethical questions. Who owns lunar resources, and how do we protect historic sites? International cooperation and new laws will be essential to ensure the moon is shared fairly and responsibly. The moon is our testbed, not just for technology, but for our wisdom as a species. Every decision we make here will echo into the future, shaping how we approach new worlds and challenges. How we answer these questions will set the precedent for humanity's future among the stars. The choices we make on the moon will define not just our lunar civilization, but the next great chapter in the human story.